In this video, we'll be solving the integral 1 over 3x squared plus 2x minus 1. The first thing we're going to do is factor out the 3 here in the denominator. And the whole purpose of this is to complete the square. So whenever you complete the square, you always want to have the coefficient of x squared to be 1. So the way we're going to do that is by first factoring out the 3. And then the minus 1 is just going to be pulled to the side over here. Okay, next we have to take 2 over 3 divided by 2 and then square it. So take half of 2 over 3, which is 1/3, square it to get 1/9. So that's what we add over here. But really, we're not adding 1/9, we're adding 3 times 1/9. 3 times 1/9 is just 1/3. And so because we're adding 1/3, we have to subtract 1/3. So this simplifies. Now the inside just factors into x plus 1/3 squared. And then minus 1 minus 1/3 is just minus 4/3. Now here, I'm going to make a u substitution. I don't like x plus 1/3, so I'm just going to let that equal to u. So then du is dx. And at this point, this doesn't look quite nice. So I'm going to multiply top and bottom by 3. And the reasoning is I want to get rid of this 3 here in the denominator. Now the 3 is going to distribute. We're going to have 9u squared minus 4 in the denominator. But here, it would be nice to have u squared minus 1 in the denominator. Okay, so thinking backwards, well, I have a 4 here, so what if instead you had 4u squared minus 4? Well, that would have been a lot better than 9u squared minus 4. So what we're going to do is make a substitution. We're going to let u equal 2/3 v, and then du will be 2/3 dv. So then when we do this, eventually we're going to have something like 4v squared minus 4. So we'll see that in the next slide. But at this point, we just make the substitution for u. U is 2/3 v, and then du is 2/3 dv. Okay, now we're going to cancel out the 3's here. And then we have 2 remaining. We have 2/3 squared is 4/9, and then the 9 is going to cancel. So that's going to leave us 4v squared minus 4 in the denominator. And then we can factor out the 4 and get 2 over 4 is a half, so I can just factor that out. And here we can break this up into 2 fractions. So technically you should be doing a partial fraction decomposition. So I'll just kind of quickly go over that here. So we know that this factors into v minus 1 and v plus 1 in the denominator. So if I multiply both sides by v squared minus 1, I'm just going to get this. 8 times v plus 1 plus v times v minus 1. So you would just have to check v equals -1 and v equals 1. If v equals -1, this thing goes away. So you're left with -2b is 1, which means b is -1/2. And then when v is 1, this is 0, so you're left with 2a equals 1, and so a is a half. So that's how we get this. Okay, then we know that 1 over v minus 1 and 1 over v plus 1 is just going to be the ln v minus 1 and ln v plus 1. So here we can bring this all into one log. So we know that, well, before we do that actually, I want to distribute out the 1/2 to both of them to get 1/4 as the coefficient. And then we had let u equal 2/3 v. So then v will be 3/2 u minus 1, or rather 3/2 u. And then we're going to subtract 1 and then add 1 here. And then make the substitution. U was x plus 1/3. So here we can do a bunch of simplifying. We'll distribute out the 3/2. And then afterwards, we're going to subtract 1. So I skipped a couple steps, but basically you get 3/2 x minus 1/2. And then here, same thing. You get 3/2 x plus 3/2. And then finally, I can bring it all in the natural log because they both have the same coefficient here, 1/4. So factor out the 1/4. And then you just have ln of this inside divided by this inside. And now we could just multiply by 2 top and bottom, like inside the natural log. And so the denominators will just cancel, and you'll be left with 3x minus 1 over 3x plus 3. And so that is our answer.